science of how diseases spread and what goes on with that, then you are in the right place. And we are happy to be here with you. Like I said, I'm Daniel Friend. My background is not in medicine at all. I'm a freelance editor, and I do some writing as well. As an editor, though, I am kind of also a professional researcher for people when they write books and they want to include things. Part of my job is to go and find out if they are actually getting their science right, or at least close enough that it's believable, especially if you're making up your own disease. But my wife is a medical laboratory technologist, which means she does all sorts of blood tests, urine tests, stool tests, and other things to test for parasites and other diseases that...
You're supposed to be eating while you're talking about that.
Oh, yeah. I just finished eating. So I don't personally have background in that, but I get to hear about it all the time, and I was able to talk with her a bit for this panel as well. So we'll have you guys introduce yourselves next.
I'm Erin Kearsley. My nice day professional job is being a nurse. I work in the ER, so I see lots of people coming in with all sorts of diseases and fun stuff. I've been doing that in the ER specifically for about a year and a half. So that's my expertise in this realm.
I'm Derrick William Dalton, sci-fi novelist. I've got this book out here and the sequel, and then there are some short story, some minor characters who were just really fun and I couldn't leave alone. So I did some short stories in a compilation for them. I'm currently working on a young adult science fiction novel with some traditional publishing people interested. So that's exciting for me. And when I'm not doing that, I'm a physician assistant. I currently do urgent care, and before that was in primary care. So I don't get to see probably the awesome stuff that you get to see. Sometimes I get to see it and say, you came to the wrong place, sir. You have somebody that can drive you somewhere else. Or, I'm going to call you an ambulance, will you please stay right there? And unfortunately, about half the time people argue with me. Dude, I'm trying to save your life! So, I also used to teach high school biology and learn lots of pestilency stuff like that. So because this is disease, we're going to be talking about gross stuff. And just to get the grossest stuff out right now so everything else is not so bad, 2 months ago I saw my first syphilis chancre on a guy's penis. And yeah, it is as gross as you think it is. We have an outbreak of syphilis in Spokane, and I think, what the 1700s is going on? So, yeah, if you want to know more details about what syphilis is like, we can talk later, but I don't think we're going to discuss anything more gross than an oozing, open syphilis sore on someone's genitals today. Aren't you glad?
We could do elephantitis.
That might be entertaining.
Anyhow, let's talk a little bit more generally before we get into specifics of diseases. We say the title of the panel is Pandemic. What's the difference between a pandemic, an epidemic, and just an outbreak? What are the levels of disease that we're talking about here?
It's also endemic.
Indeed. Did you want to be up here?
Sorry.
So, walk us through what the differences are with these things. What's the difference between an outbreak, just an epidemic, and a pandemic? What are we talking about here when we use these words? Oh gosh, did I stump the panel?
No, it's like who wants to do it?
Oh, ladies first. I was being chivalrous.
Okay, thank you. So an outbreak is just kind of a very localized sort of thing where you're seeing more of it than you're used to seeing in one fairly local area, a city or a few cities, a fairly small area. Sometimes
so
even
Spokane for syphilis.
Yes, for that example, that's an outbreak. An epidemic is much larger. It can be as large as a nation, or several states, several regions, anything that is covering and crossing several borders within that. Sorry, Carrie. Sorry.
Okay.
Yeah, I'm good, thanks. And then to go to a pandemic, that's when it crosses national borders and it's in multiple countries. That's when you hit the pandemic level.
Okay. All right. Would you like to introduce yourself and join the panel?
I'm so sorry I'm late. My name's Carrie Harris. I am an author and a game designer. Before I became those things, though, I was the manager of the National Prion Disease Pathology Surveillance Center, which is a fancy name for the place that's in charge of surveilling for mad cow disease epidemic. So, oh my gosh, I ran. So I worked with the CDC on monitoring potential cases, and so this was kind of what I used to do before I made things up for fun.
I'm so glad you've joined us.
Yeah. So sorry, I was late.
So we just got some good definitions of what pandemic versus epidemic versus outbreak are. Anything to add to that?
A specific example of epidemic being kind of a localized thing. For the last, 10 years or so, vaccination rates in the state of Washington have been slowly coming down. And so we get an epidemic of pertussis every year. And there's always an infant or two that dies.
Pertussis?
Whooping cough.
Yes. And that's really sad because the vaccination is fantastic. And recently, because Spokane is one of the places in the United States where a lot of refugees from other countries are relocated, which I think is an awesome thing, and it makes me so proud I can forgive the syphilis problem. But we also have an influx of people with low immunization rates. And there's a pretty big Marshallese population from the islands and very low MMR, measles, mumps, rubella vaccination rates. And so there has been a localized epidemic of that, in that so if something's endemic, it means it happens all the time, the usual rates. So we get a certain amount of flu every year, we expect that. And we expect 0 mumps. So when we get any, then that is, and it persists, and it's through that big area we have an outbreak. Because and this is kind of gets into how you'll design diseases, because I have had several people tell me they want to kill off the world, which is awesome.
There's an app for that.
That's great. So with like pertussis, for example, vaccination is great. You get it once as a kid, you get it again as an adult, you're good to go. With mumps, it's about 85% effective. So if you've got a group of people 100% vaccinated, then if you think of it as like a surface area, the people out here get exposed, very few of them are going to get it, and then they're going to transmit it to even fewer of the people inside, and so you have what's called herd immunity. And it's hugely important in the mumps, because the vaccine, the best we can get is 85%. So I had a teacher come in, starting to swell right here. I think I got the mumps. Okay, because now everybody comes in. I got the mumps now. And the teacher next door to me just got diagnosed with the mumps yesterday. And we've had 4 outbreaks, or 4 cases of mumps in our school. Like, okay, I think you do have the mumps. Let's get you tested. Kind of a longer definition.
So now that we've started talking about herd immunity, I mean, before we get into how to prevent diseases from spreading, let's talk about how they spread naturally. Let's talk about what are the different ways that diseases can be transmitted, and what does that mean for a population? Especially, we should keep in mind that a lot of our audience here is going to be science fiction or fantasy writers, so if you have any thoughts about what this would mean back in medieval ages, or possibly what that might mean up in space in an enclosed capsule environment or on another planet, or what an alien disease might do, if you're really feeling adventurous, feel free to mention that as well. But so, what are the ways that diseases spread, and what does that do to different populations?
Well, when we talk about medieval, that brings up the fecal-oral route. So the disease is in your poop, and if it's on your hands and then you eat something, then it gets into your system, and that's how you get sick. This is how cholera spreads, and a number of other things, E. coli, similar things like that. So that's a big issue in medieval times when you don't have proper sanitation. Sorry. So when you don't have proper sanitation, when you don't have plumbing, then those kinds of diseases are going to be an issue. Things that cause diarrhea and that kind of thing. That's kind of one of the first types that comes to mind with that. Go ahead. We'll just go down the road.
Yep. So you talk about fecal oral. There's also the airborne droplets. coming from the lungs. I guess a good example of this would be looking at the chickenpox virus. When somebody gets infected with that, the virus is replicating in their cells, makes the cells die, and it barfs out virus particles all over, everything else gets sick. So they're coughing and breathing out virus particles before you get the little itchy, obnoxious spots. And those are also secreting virus particles, so you can get it through contact, or you can get it through inhaling ones. And
So if you touch the pox, does that count as a fluid transmission then? Because they're pussy, or does that count as just touching it all?
It's in that fluid, and it can get on you, and then it can get in you through that route.
Okay.
It goes dormant, it goes away, and most of the time never comes back. But we're seeing more frequently in the elderly population, and I've seen it more than really what you expect to from what the textbooks say in younger populations with stressful events, because that is a killer on your immune system. And so you have this virus, and this is so science fiction-y, I think. This is really real? Somebody just make this up? But it goes dormant along your spine, like something from a alien movie. And then your immune system is just keeping it in check, and it's not really doing anything. But something happens, your immune system takes a dip, and then it starts to spread. And in between each of your vertebrae, you've got a nerve root that comes out. And the sensory component of that goes along a very specific stripe around your body, down your arm. If you look up dermatome map, DERMATOME, there's all really good pictures of it, and you can actually figure out, I've got the shingles spots show up. If it's a line right down here, you can look at the maps and figure, okay, that's from like my C3, C4 vertebrae location, that's where the virus is. And if you catch it soon enough, you can take some antivirals that will make it a little less painful, help you clear it sooner. But for the most part, you just got to ride it out, and it really hurts. It's not doing any damage to your nerves. It's just poking your pain nerve receptors all the time, like some jerk behind you with a needle going like this, and it's miserable. Sometimes it can be really bad. In the elderly population, you can get some pulmonary side effects from it. So that's shown like you got the oral and inhalation route. But then with the shingles vaccination, you're not doing that. You're not exhaling anything. You're secreting the virus a little bit from the fluid, but it's really not enough to make anybody sick. You don't have to worry about it unless you got somebody in your house who's immunocompromised from like medications from an organ transplant, if we got late stage HIV, that sort of thing. It's just your own little misery you have to deal with.
Another interesting concept to deal with, especially from a speculative fiction point of view, is animal transmissions, where a virus or some kind of infectious particle, because I'm going to open that up since I'm a prion person, I'll talk about that maybe in a minute, and it gets into an animal host, and that's where it changes. And so if you're looking for a place to create a new disease, that's an interesting way to do it. We have bird flu, you guys are familiar with, you're familiar with West Nile. Anybody familiar with the zombie ants? Yeah. I love the zombie ants. So my first book was a zombie book, and I based a lot of the infection on my work with prion diseases, and as a part of that I had to research. And there are zombie ants. It's a spore that infests ants in the Amazon. But what it does, and the neat thing about it, is it forces them to walk to a place where lots of ants tend to pass by or congregate. They tend to make the same paths, and it waits. When they come by, it grabs onto a piece of grass or something like that. The spore grows out through their head, waits for them to come, grabs on, and explodes.
Their head explodes.
Yes, the spores release and infect all the other ants. Now that shows some kind of, there's definitely a deliberate propagation mechanism, because it doesn't just go anywhere. It doesn't just go to a place where there's lots of ant spore and then release. It waits for them to come.
Please, someone write a book about that.
There's also Toxoplasmosa gondii, which infests rats and makes them run toward cats instead of away from them because it replicates in cat stomachs. So it makes the rats want to be eaten. It's Toxoplasmosis gondii, Gondii. Another
Lots
cool.
of people
That's
are
a bacteria?
We're infected too.
Bacteria. And the zombie ant, that was a fungus?
It's a fungus of
Fungus.
some kind, but I don't remember the name of it off the top of my head. But if you look up zombie ants, it's actually in
National Geographic.
National Geographic. That's it.
So cool.
Yeah, so you can look up that stuff. And so when you're thinking about disease transmission from a creative standpoint, look for vectors that you haven't seen before, that you haven't thought of. One of my favorite, I feel weird saying one of my favorite diseases, but I'm going to go for it. One of my favorite diseases is called Kuru. And Kuru is a prion disease, which is misformed proteins in your brain. That's what mad cow disease is. So it happened, there was a sporadic case, meaning it popped up, we don't know how or why, but it was in a small tribe in Papua New Guinea. They practice ritualistic cannibalism. The entire tribe ate the deceased as a gesture of respect. The tribe is no more. They all caught it. So think about those unusual vectors, things where people have contact with fluids or infected, contaminated stuff.
Now, as an editor, I'll chime in here a little bit as a panelist. You've got to keep in mind your setting with this, because if you are in an enclosed space station habitat, airborne is the worst thing in the world, because that gets into the air ducts and it ventilates through the entire station, and then everyone is sick all at once. If you're in a terrestrial environment, maybe waterborne is worse, because everyone has to drink water, and maybe there's only the one source in wherever you are, or maybe it's just everywhere and everyone would get infected from it. So pay attention to your source, and keep in mind that sometimes sources are not always what they appear to be. I was just in the green room talking with Howard Taylor, and he shared a story that I'm going to share with you. Up at Aspen Grove, which is a little kind of resort thing up the mountain, there was an outbreak of a parasite called Giardia. Giardia is a fun little parasite. If you look at it under a microscope, it's a little pink dot with a smiley face in it. It really looks like a smiley face. Google this.
Very ironic.
Yeah, it does not make you happy. It might be happy, but you're not. At any rate, there was an outbreak of Giardia. Giardia is what was mentioned, a fecal-oral transmission. Normally, that's something that is in your stool, and you poop it out, and it doesn't do too much. But if you then eat it, that's a problem. And so it's like, well, somebody has been handling the lettuce at Aspen Grove without washing their hands after they went to the bathroom. Who's the gross person? It turned out that wasn't what happened in this case. Their water system was set up so they had a big tank up on the hill, and then the water came down. Now, there was enough pressure in the whole pipe system under Aspen Grove that they lost about 5 gallons a minute. That's not a super huge amount when you're talking about a huge complex of pipes. However, one day, somebody used up all of the water in the tank, and that created negative pressure, which then sucked the sewage back into the water lines. So once the water tank got refilled and water started flowing again, it pushed all of the nasty sewage water out first. And they found that that the Giardia was coming from a drinking fountain. And that's where the outbreak had happened, rather than from the food. So, I mean, they fixed it and they cleaned it and everybody was okay. But that is how outbreaks can happen with completely unexpected causes. So that is a real-world example, and, I mean, think about stuff like that. If it's a fecal-oral transmission, where does the poop possibly come into contact with other stuff that humans need? Food, water, whatever it is. If it's an airborne thing, how does the air come into contact with people? Because usually just a sneeze only goes 4 feet, and you don't have to worry about it too much unless it goes through a ventilation system or something like that. If there's water, how is everybody getting the water? Is there a cultural tradition where you have to, put water on somebody's head for whatever ceremony that these people that you're writing about do? Is that where they're getting sick? I mean, there's all
Share a cup.
Do they share a cup? Do they pass around a cup for the communion, for instance? that can be a vector of transmission. So there's all sorts of different ways that these things can happen. Yes?
What are realistic time periods for how fast a disease spreads?
That depends on what kind of disease you're talking about. It can be days, weeks, months.
And again, it depends on the level of technology of the society that you're in. If you're talking about medieval society, it's only going to go as fast as a horse, or maybe if it's some kind of a bird flu, as fast as a bird can fly. Mm-hmm. That's about as fast as it can transmit. If you're in 20th century or beyond, then an airplane can take that all the way around the world in a single day. Mm-hmm. One sick stewardess infects 12 different cities, and you have a worldwide pandemic.
And if you're talking space, consider the effects of faster than life space travel on your, whatever your infectious vector is. If people can move that fast, those infectious particles can move that fast. So you could wipe out. Yeah, I know, right? It would be beyond a pandemic, wouldn't it? Yeah. I don't know what it would be.
Universe-demic.
Yeah.
Galaxy.
You can make up a word for that, guys. You're writers.
Maybe, yeah. Well, what she was talking about, Carl Sagan did not take that lightly, and he insisted that everything on Voyager be completely and totally sterilized. He didn't want anything living, proteinaceous, anything that could alter any kind of other biome in any way. He just wanted plastic and metal and nothing else. So it was a ordeal he made.
And that brings up an interesting question when you're talking about, say, going to Mars where there may be microbial life. If you have contaminated probes, how do you know if that life originated on Earth or not? It might not be possible to tell depending on the variables. Again, if you're going to a planet that is actually, Earth-like and has lots of life, how are those microbes going to interact with our microbes and with our animals? And how is the interaction? Some of them might be so different that it doesn't interact at all. Some of them might be just similar enough that it's the worst thing you've ever had.
Yeah. I think one of the most interesting things, if you've read the book The Martian, I really wish he would have brought back some of those potatoes and tested them. But I also think that, like you were saying, there could be an interesting story in the aftermath. He lived on Mars. What did he leave behind, and how did it interact on a cellular level with whatever is there? There's story opportunities there.
And that's a great example of where they got the science wrong in the movie, because in the book, he only uses his own fecal matter. In the movie, he's taken from the other people, and that's
very different.
That creates all kinds of problems that the movie doesn't address.
Yes.
Mm-hmm. And they didn't even need to,
No.
Well, you got that really good stinky poop joke about the German out of it.
That's true.
Oh, Johansson!
Yeah, well, that's probably the only reason why. Because there's no other reason.
Poop
The biologist would know.
What about infection rates? Because you see sometimes these books or TV shows or movies that have these worldwide pandemics that wipe out all but 0.01% of the population. Is that feasible? I mean, because there are natural immunities to diseases. I mean, what is the feasibility of total, of really wiping out a population?
Well, when you consider the Black Plague, when it was, big thing, Black Death, Black Plague, I believe, trying to remember correctly, that wiped out like 70% of the population in Europe. So, I don't know, not necessarily 0.1%, but wiping out more than half is very feasible.
Yeah. Well, and if you're talking, it also depends on, like she said, when you're talking about, because if you're talking about modern day, we're going to be working on cures. And really, the best way for some kind of infectious agent to live long enough to really do some damage is if it mutates rapidly enough to stay ahead of our efforts to combat it. So that would be one way to make that happen, would be some kind of mutagen that would stay ahead of science.
And here's where we come into a question that I'll put to the panel here, because we've got different things that can infect you. We've got Giardia, I talked about, as a parasite, and parasites can be anything from worms to amoebas to whatever else. You've also got your two major contenders, which are always bacteria and viruses, but even all of those are not created equal. The biggest example is, of course, smallpox being a DNA virus. did not mutate very fast, and so we had one vaccine and boom, wiped it out. However, the flu is an RNA virus, which means that it's got just one strand of genetic material, then that mutates very, very rapidly, which is why we have new flu shots every year, because there's a new flu every year, and it mutates so fast sometimes that we aren't always able to advance to be ahead of it and to get the right one. So with and we also have mentioned funguses before, so we've got bacteria and viruses and funguses and amoebas and parasites of all kinds. Tell us a little more about the differences between these different types of pathogens and how you could use them in stories. Let's start at that end.
Well, my background is mostly in prion diseases, so I'm going to deal with the weird stuff first.
What is a prion?
A prion disease is mad cow disease. That is an example of it. And what it is it's a protein. And that's what makes it weird. There is no virus, there's no bacteria, there's none of those things. It's a misfolded protein. When it comes into contact with other misfolded proteins, it causes them to misfold as well. And so it propagates itself and converts healthy tissue into unhealthy tissue, and it turns your brain essentially into a sponge. So one of the things about prion diseases is that prions are very, very difficult to destroy. Crematories, if they're hot enough, can do it. So as an infectious agent, if you want something that's very hard to kill, difficult to detect, something like that might be a good idea for you.
As I understand, bleach and Drano don't get the job done.
No. So that's why...
Boil in sulfuric acid.
Venus gets the job done always.
We formic acid bombed everything. So, so in terms of an option there, that's a good one that's a little bit off the beaten path. Another option from a creative point of view is to take two things and put them together. A book that I really recommend if you're looking at an excellent example of writing an epidemic is Feed by Mira Grant. It happens after the epidemic, but her concept is that the cure for the common cold and the cure for cancer were released at the same time and they interacted. So the cure for cancer is kind of the big gun, but the cure for common cold changes a lot, which is kind of what we were talking about with the rapid mutation. The result was zombies. Of course. And it sounds campy, but it is one of the best, most chilling books I've ever read. I screamed and I threw it across the room at the end, so you are warned.
There's two sequels. You can scream at them too.
You can multiply scream, and now there's a prequel. So I'm going to leave the viruses and bacteria for you guys, but I wanted to give you the weird stuff.
Can I take fungi?
Do it.
Okay.
They're fun.
It's like science fiction, and it just creeps me out. And they're not an animal, and they are not a plant. If you look at them, their cell membrane and everything inside there, it looks like an animal cell. There's no chloroplasts in there, so they can't photosynthesize, but they have a cell wall like a plant does, only it's not made out of cellulose like a plant, it's made out of chitin, like an insect exoskeleton. And yeah, so like these, it's a armored bacteria almost, but it can't move, so it has to do something else, like the spores, or get the zombie ant to move for you, or I can't look at these anymore without thinking weird sci-fi stuff. But you've seen people's lawns, and they've got a ring of darker grass that's taller. That is the fungus. That's the organism. That's the size of it. They just grow huge. There's one in Michigan that is like 1.5 miles. They drill in the ground and take samples and DNA test it, and they just keep going, and it's the same genome, 1.5 miles large fungus. So they're hard to kill. Because they don't move, they can't get their food. They can't get their food to them. So they just secrete digestive enzymes, and then they grow through it. Grow. And that also creates fertilizer, and that's where you get that darker, greener grass. Anybody? Nobody
We will
raise
never
their hands.
look at athlete's foot again.
Right. Or ringworm. I'm not much of a sports guy. I didn't have kids in sports when I was doing primary care, but I knew when wrestling season started, so all of a sudden all these little boys would be coming in with this ring on their arm that's dark red and then more pale in the middle, and it's kind of scaly. And that's the size of the fungus. It's barfing in their skin, stomach acid, and then growing through it and eating the dissolved skin cells. And it doesn't get down into the dermis and cause any problems. Some of that digestive stuff does, and that's what makes it red and irritated. So it's cosmetic, essentially. But it's still gross. But all of that stuff, just, you read about that and you can't help but extrapolate each one of those little ideas into something awful. A 1.5 mile sized organism, well, what if that's in space? What if that chitin can resist radiation? And so,
what if you've got a world that's just one supercontinent and then a ring that expands and covers the entire planet with a fungus?
What if the world is the fungus?
You guys are creeping me out.
You land on a new world.
Free writing tips, people.
Okay, so getting to the slightly more generic or run-of-the-mill stuff, bacteria and viruses. Bacteria, we have a pretty good way to fight. We have antibiotics. But because we've been using antibiotics so long, you get antibiotic-resistant strains, and that's a real problem. One that we hit a lot of time is MRSA, MRSA. It lives on probably half the people's in this room's skin. It doesn't cause you a problem until you get a cut and it gets infected with that organism. And that can be a real problem to try to fight it. It's also a problem with tuberculosis. We don't see a lot of that here in first world countries, but it's a major problem in third world countries where it's resistant to the treatments that we've done and figured out. And so now there are all these people dying of horrible lung disease and we don't know how to fix it anymore. And so that's where you can kind of get into the realm of, okay, is there a new resistant antibiotic, some new bacteria that's resistant to the antibiotics that we can play with, and it can be insidious that way. Yes?
Is there any way to kill a bacteria with that, other than an antibiotic? Like, what does an antibiotic do?
Your
exactly?
white blood cells are really good at killing bacteria. And what your white blood cells do is they surround the bacteria and then they bathe it in ammonia or something equally nasty or bleach, and it just kills it. It penetrates the membrane, destroys the DNA. That's what your white blood cells do. Antibiotics try and make it so that the bacteria cannot live in a certain space. It prohibits them from digesting or from reproducing, or some of their life functions are somehow compromised by the chemical. But if you go and look online for look at bacteria or antibiotic-resistant bacteria, and they have a big agar plate, like 3 feet wide, of that's lined with different antibiotics, and it gets stronger as it goes in toward the center. So the weaker antibiotics are on the side, and they put bacteria on the edge, and they do a time lapse where you can see the bacteria grow, and it'll hit the antibiotic wall, and then one bacteria will change and adapt and mutate so that it is resistant to that antibiotic, and it'll just spread out until it hits the next wall. And then at a different point, it'll spread out until it hits the next one. And it shows you evolution in action right before your eyes. I don't remember the title of it. Do you guys know what I'm talking about? I
haven't seen that.
It's really cool.
It's a cool graphic. Yeah, you could probably Google, antibiotic resistant.
Yeah, antibiotic resistant bacteria on YouTube, and you'll probably be able to find the video there. I did see a question over here on the floor.
Yes, I was wondering. So infection rates. There are, as you were saying, and there are certain things that are around us all the time, and we only, or where you think, you have to. The more you're exposed, the more likely you are to come down with it. But with prions, on the other hand, it sounds like if you're exposed, it happens. Period. So I guess I'm just curious about the range that there is in, once you're exposed, how likely you are to get infected by different things.
Infectivity is what that's called.
Okay.
And there was some research studies done. I had a professor who was actually involved in it early in his career, and he's since retired, so that study puts it about the 1970s. And I don't remember the bacteria. It was an enteric virus. It caused diarrhea. It wasn't fatal or particularly harmful, but they didn't know how many actual bacterial cells you have to ingest before you get sick. So they had a population of prisoners, and they would put in a capsule. They just did a exponential growth. They did 10, 100,000, 10,000 million, and so on. And they would have different groups of the prisoners just take that pill. And I don't know, I'm a nerdy guy, but if I was a prisoner, I'd think, hey, I'm contributing to science. This is good. You can't do stuff like that anymore, but they found out exactly how many bacteria you had to ingest before you would get sick. So exactly what the infectivity
for that particular
was
one.
For that,
so, but those vary a lot from.
Yeah,
I guess.
They do, and one of the other variables to consider is dormancy. How long does it stay dormant? You know, I'm going to go back to prions, I'm sorry. But they're incredibly infectious at very tiny amounts. So why didn't everybody get it? If it got into the food supply, which we know it did in the UK, why didn't everybody get sick? Well, it turned out there were actually two limiting factors, and one was dormancy rates. It's dormant for about 15 years. So some of the people who were exposed are no longer alive. The other thing is that it only affects people who are...
You mean alive, they died from something else?
They died from something else. Yeah, they died from something else before they could exhibit symptoms. The other thing that's interesting about that strain of prion disease is that it only affects people between the age of 15 to like 23. So in terms of who it affects, which is really weird, you know, you can dial in or dial out how fast you want your disease to spread by giving it limitations or removing them.
Now, normally diseases like to hit people who already have weak immune systems, babies, the elderly, people who have an immune disease of some sort, be that leukemia or AIDS or what have you. But there are some diseases that do the opposite just for fun. So you can do what you want to do if you are inventing a new disease. You can combine pieces of two diseases. If you've seen Contagion, the movie Contagion is like, well, the wrong bat met the wrong pig, and pieces of the two viruses came together, and boom, new virus. That happens. You can do that. And especially if you're going to an alien world, you can do literally anything you want. Yes?
So, I'm not sure if you're familiar with the video game Plague Inc.
Yes.
And the board game.
That's the app.
Yeah, well, I have the PC version. Anyways, so as I'm playing this game, obviously it's striking some science fiction writer chords in me. Mm-hmm. And I have been wondering, what are the implications of having a pathogen that are controlled by a malicious sentient force, and or like you were saying about the prions and like what they do, the possibility of like developing sentience within a pathogen? What are the implications of that? How would we fight it? What would we even do?
Now that's a good book premise. Write that, please. I want to read it.
I already wrote it.
Yeah, there's a lot of stuff going on, and there's two different questions when you're talking about. There's the question of what about people who are trying to release something really horrible for nefarious ends, and then there's intelligence within the pathogen itself. Those are two different things. People trying to release it, it's what they release is going to depend very, very much on their goals. So if, for instance, you have, let's suppose that you have somebody who is a white supremacist that thinks that only white people should be alive. They will make sure that this particular bug cannot infect white people from whatever genetic thing that they think makes somebody a white person, but that it is geared to attack genetic codes that are only found in non-white people, and that's how they're going to design the bug, and they'll release it in a place that is not white heavy and where it's going to spread, and that's the kind of bug that particular villain is going to want to design.
Or it's dormant in white
people. Or whatever, or what have you. You can have those different types of things. So that's what that villain's going to want to do with it, and he's going to make a bug that's tailored to his desires. Now, the bug that gets sentient on itself, that one I'm a little bit leery of because these things don't have brains.
Exactly. Well, there is though an X-Files episode. It's the black oil stuff. I was trying to look at what it's called, but it's the black oil virus, but it's alien in nature. So it's not created, but it is it is an organism that when it comes to us, it turns out that it can infest us. So that would be one example of how to do it well. Another...
There's an example in Night Train to Rigel with a fungus that... brain-controlling fungus that has a core thing that spreads to other people. And
yeah.
I see it as more feasible with a fungus or a bacteria, because with a virus, it's got the genetic code to create some kind of a protein that will attach to a protein on a cell and adhere to it. And that allows the RNA or the DNA to get injected into the cell. And then that will plug into the DNA or RNA of that cell. And then as the cell does its normal thing, copying the DNA, it inadvertently starts cranking out these virus particles, and eventually it burns the cell out and they fall out all over. So with that sentient thing, it would be like some code. And you could insert new code into somebody's brain, but then to change it all the time would be difficult. But with the fungus, that would seem more plausible because they can have more stimulus response with the outside environment.
Fungus can become complicated. Like, I mean, you look at, most funguses aren't just little molds that grow. I mean, you're looking at mushrooms, and you're looking at, tendrils of things, and funguses can get discrete parts, and they can be complicated organisms. You can get big ones like we were talking about that are half a mile wide. So fungus can diversify enough that it could actually get intelligence somehow. Bacteria are just really small, and they aren't necessarily working communally in such a way that, like ants, that they would be able to do that. Viruses, like was just explained, do one thing, and that's it. That is the only thing that viruses do. So probably if you want actual intelligence in the pathogen itself, you're looking at a fungus of some sort, which is exactly what they did in Halo with the Flood.
My son was eating mushroom once, and I felt like giving him a hard time. So I said, if that fungus had genitals, you just ate them. Look on his face, I should have had a camera.
I was wondering, how feasible is it to think that I get a virus and it changes my DNA so much that I become a werewolf or something like that?
With viruses, that's hard because, like we said, they do one thing. With bacteria, that's a little bit different because a bacteria your cell might decide to eat a bacteria and eat part of it and assimilate part of the DNA. Usually that happens on a one-cell basis, and that one cell dies, and it's not that big of a deal. If there's something, and this is science fiction, not science, if there's something interesting about this particular bug that makes it so that it really wants to adhere to your DNA and change that, that's the science fiction element, and you could probably get away with that with enough technobabble. That sounds good. So,
what you're talking about is genetic engineering, and you've got those sections of the virus that code for the proteins to do the infection stuff, and there's also the section that causes that create the proteins that cause the problems. And so chopping those out, replacing it with something else. I was at the University of Calgary doing research for a little while, and shortly before I'd gotten there was a research group that would, I think it was with radiation, they would destroy the pancreas of these rats, essentially giving them type 1 diabetes. And then they had a virus that they had taken out the virulent component to it, and they had put in the strand of DNA that creates insulin. And then they infected the rats with that. I think it was a hepatitis virus. And so it infected their liver, didn't cause any problems, but their liver cells started cranking out insulin, and they cured type 1 diabetes in these rats. They couldn't regulate it up and down the way your pancreas does, but it was there, a steady stream of insulin. So you take that and just make it more complex. The changing back and forth between the werewolf, that would be the total fictional part. But creating some kind of mutation like that was just one time and permanent would be awesome. And potentially, Mythbusters would call it plausible.
And you could have that be something that people do on purpose, especially. Because that's probably how it would happen. Other questions? We are getting down to the last few minutes or so, but yes, right here.
You were talking about genetics. Is there some way to transmit that besides like family tree line or besides cannibalism per se, like to affect things on a genetic level? I don't know if that makes sense. Sorry.
If you release a huge virus that's going to genetically engineer, a large population, you could modify a virus to do that. It would have to be consciously done.
Yeah, for it to happen spontaneously, I don't know of any ways that would occur in nature. But to have somebody do it, there are a few ways.
Yeah. If you wanted to create a multi-generational virus, it just comes down to which cells in the body. All the somatic cells, which is everything except the cells that produce eggs and sperm. Any DNA changes on those die with that individual. But if you got changes to the DNA in the eggs and the sperm, then it gets passed on to the next generation.
So if the virus can lie dormant in the testes or the ovaries, and that's where it lives, and it's infected those cells, then you can have that change. And that's actually something that people have thought about for genetic engineering. We won't change you, but hey, we can change your sex cells so that your progeny don't have crooked teeth or acne or whatever it is. People have thought about doing that kind of stuff. We're not to the point where we can yet, but people have thought about it.
Mm-hmm. We've talked about various things that can kill you, but how do they kill us? Why do we get sick?
That's a whole panel.
Yeah. We have 4 minutes. I don't think we can answer that whole thing.
Biology of death. If you're looking like at the cellular level, maybe some of you are at the mechanics of death thing, but with something causes the cell to lose its ability to maintain ions and water concentration and get energy. With a virus infection, sometimes it's just the volume of virus particles rupture the cell and its guts spill out and it's gone. And then its dying act is to send all these particles out to its buddies that are going to kill it. And as far as taking from that to the organismal level, if at some point your kidneys aren't functioning well enough to get rid of ammonia or to pull back in the glucose and electrons before all that fluid goes to the bladder, then you're going to have problems. If your liver enzymes are spilling out into your blood, and you see pictures of people with really nasty hepatitis and their eyes are yellow. I had a lady come in, not as the patient, with her husband, and we could turn the lights off and it would be like a kitty. I swear, her eyes were her skin was yellow. And I was trying to be very tactful about it, and I said, is there a primary care provider that you've been seeing recently? And she kind of, here we go again. Somebody thinks that I'm completely a mess, because she was completely a mess. She said, yes, my liver's being watched. And that was enzymes from the liver spilling out, not reconfiguring the heme from the blood, and it's turning all yellow. And eventually those toxin levels can build up to the point where then the kidneys fail, or the cells everywhere else it's creating toxic levels. So it starts with the cells. What happens to those cells? Which cells in the body is it? And then you can just extrapolate from there. So that's a really fun thing to play with.
If enough cells in an organ explode, that organ stops working. And then if it's your lungs, you can't breathe. If it's your brain, you can't think. And if it's your heart, you can't beat.
That was a much better summary than what I said.
One final question in the back, and then we're done.
Okay, what about diseases spread by blood-to-blood contact? Is there anything special that they can do?
They can do about anything other ones can do. That's just more limited in their transmission.
It's a lot harder to get them. Other than that, they can do anything else. So, all right.
Can I make one more comment?
Please.
A really good resource would be a book called The Control of Communicable Diseases Manual. They put out a new one every year, and it lists every disease, and parts of it's just in a table. The period of infectivity, how long the incubation period is, how long symptoms last, what the symptoms are, the treatment. It's really quick summary. It's awesome. There might even be an online version of it.
Did all of you recommend good book resources or places
All right,
to do
last
research?
words. We have 1 minute. Go.
Okay, not necessarily a book, but look up lists of reportable diseases in your area. That's going to tell you what the Centers for Disease Control and other important peoples are concerned about possibly breaking out. So that's a good place to start if you're looking for
Here's the
infectious
list for
agents.
Utah, for example.
Yeah.
Found that on the internet yesterday. It was fun.
Control of Communicable Diseases Manual, just in case you didn't catch it the first time.
All right. Thanks for coming, guys. Good to be your audience.